Hi, I'm Mr. Franklin, and this is part two. This is an advanced metric conversions. So if you want to know more about how the metric system is kind of put together, you can see my previous video. But in this video, we're going to go to the extreme ends of the metric system and take a look at how to do basic conversions with them. Usually you will need this in chemistry for doing energy of light, frequency of light, converting nanometers to meters, using the speed of light, those kinds of things. You can also see this in physics when we get into particle physics and extreme speeds, those kinds of things. So yeah, so let's take a look. So, wow, we have our base tower here, our base ladder here. We have King Henry died while drinking chocolate milk right here in the middle. King Henry died by drinking chocolate milk. But then we have our extreme end. So on this end, we actually have what's probably most familiar. We have exa, peta, tera, giga, mega. So kilobytes, megabytes, gigabytes, terabytes, right? Okay. So we have peta and exa at the large end of things. Okay. On the smaller end of things, we have deci, centi, milli. Then we have micro, nano, pico, femto, and atto. Now, when we're in our ladder here, each step is separated by a factor of 10. We're either multiplying or dividing by 10. So times 10, times 10, times 10, or divide by 10, divide by 10, divide by 10. However, when I go from kilo to mega, we should all remember that a megabyte is 1,000 kilobytes. So there's 1, 2, 3 steps to mega, okay? From mega to giga, there's 3 more steps. It's 1,000. 1, 2, 3. Let me change my color here. So 1, 2, 3, and then giga to tera. 1, 2, 3. Tera to peta. 1, 2, 3. And peta to exa. 1, 2, 3. So when we get into these, we're going to be multiplying by factors of 1,000, or moving the squiggly, moving our decimal 3 places. Same down here, milli to micro is 3. So 1, 2, 3 to micro, 1, 2, 3 to nano, 1, 2, 3 to pico, 1, 2, 3 to femto, and 1, 2, 3 to atto. Now, most likely you will find this memory device called a mnemonic for King Henry died by drinking chocolate milk for the center. I always had a problem when I started getting into this, keeping which one goes where. And so I came up with one of my own for the rest of it. So every person thinks George made King Henry die by drinking chocolate milk, missing no pinkies Friday afternoon. Which is crazy because I remember that and I remember the order and I don't have to think about it very hard. It seems weird that I'm actually memorizing more information than just memorizing it, but it helps me. Now, generally in chemistry, you only deal with this end. And this and kilo, okay? It's really only in physics that we tend to get up here because we're dealing with extreme ends of things. So when we start talking about galaxies and all that kind of stuff, we could be talking about these things. Down here, we're talking about the atom and very, very tiny things. So let's take a look at what this looks like for a unit conversion. So let's try one, 0.25 grams to micrograms. So this micro is the Greek letter mu. So it's basically an M, but it's got a little U-like tail to it. So when I get this, first thing I go is it's on the small end. So I only write King Henry died by drinking chocolate milk, mu, micro, nano, missing no pinkies Friday afternoon. So I'm going from grams, my base unit, and I'm going to micro. So that's 1, 2, 3, and then 3 more, 4, 5, 6. Okay, so when we go from milli to the next one, it's 3 steps. So 1, 2, 3, 4, 5, 6 to micro. So I'm gonna move my decimal 6 places. And we're going to the right, so let's do that. 1, 2, 3, 4, 5, 6. So that's 20, 5, and then 3 zeros. 1, 2, 3. 25,000 micrograms, which that's hard to type. So generally, if you're dealing with that, I would prefer to write it. You just make like a U, like a cursive U, and then you put a little tail on it, on the leading edge of it. And that's micro. And I always do mine on the wrong side, just saying. So anyway, 25,000 micrograms is equal to 0.025 grams. All right, let's take a look at another one. This one is one you will do in chemistry, or could potentially do in chemistry, because you'll look at a beam of light and you'll see its spectrum, and you can read what color, what the wavelength of red light is. We actually might do this in our class as well. And the wavelength of red light is 450 nanometers. Okay, so that's nanometers. But when we're dealing with the speed of light is in meters per second. So we can't do math with nanometers and meters per second. We got to pick one. So generally, I tend to pick meters, okay? Because most everything we do will be in meters, and it'll just make your life easier. We're still dealing with the small end of things. So King Henry died by drinking chocolate milk, missing no pinkies Friday afternoon. So we're starting at nano, and now we're going to meters. So we're going to go 1, 2, 3 to micro, 1, 2, 3 to milli, and then centi, deci, and then meter, our base unit. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Nano literally means 9. Okay, so we're going to be dividing by 10 by 9 times, or move the decimal 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I fill in all those with zeros. So 0, 1, 2, 3, 4, 5, 6, and then 4, 5. Okay, and that would be in meters. This is really where we should be getting into scientific notation, because I don't like the way that looks. We would convert it to scientific notation, and if you know some exponent rules with your math, it actually makes the future math much easier, and hopefully I'll get to show you that as well. All right, let's take a look at another one. Go ahead and pause it and try this one on your own and see what you come up with. All right, welcome back. Let's take a look. A little tricky this time, went to the other end of the scale here. So guess what? King Henry died while drinking chocolate milk. And then we got every person thinks George made King Henry. So we've got Tara, and we're starting at meter. We're starting at the base unit. Oh my goodness. So that's going to be a lot of zeros. 1, 2, 3. Yeah, that was horrible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, 12 decimal places. And we're going to the left, so we got to move our decimal to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And usually if I run into the problem I was kind of running into there, where the typed numbers are too small for me to move my pencil, I will actually rewrite the whole number and do it, because I do not like making mistakes. 1, 2, 3, 4 zeros, even though I do all the time. 1, 2, 3, 7, 8, 7, 9, 1. Tera meters. Okay. Super, 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 super tiny. Okay. Even though 12,378,791 meters is a lot of meters, in terameters, it's pretty small. So that's the basics of it. Generally in this class and most science classes, you will do kilo, and that's about where we stop. If we go beyond kilo, we're probably jumping into a completely different set of units, like astronomical units, light year, things like that. because they're even bigger than some of these others. So when we talk about energy, you might see exa and peta. When we're talking computers, you'll definitely see that. Petaflops has to do with how many operations a second, which is not the same as processor speed. So we do use it for other things as well, but mostly in the sciences, you will deal with the smaller end of things. All right, so there are some exercise problems for you to work on with these as well. So have at it. Let me know if you have any questions. Thanks. Bye.